Hi guys, for today's lesson we're going to be dealing with some logarithmic laws that we need to kind of take on board. So when working with expressions or equations, you need to be aware of opposite or inverse operations which can cancel with each other. So you're going to be dealing with these logarithmic expressions. You need to be aware of when things can cancel, because obviously we want to try and make things as simple as possible for us whenever we can to deal with, to make these situations easier for us. So here is our first situation when you're dealing with the log base A, which is being applied to a base of A, which are considered to be opposites. So these two things will cancel, leaving us with this power of x to be what this thing equals, this x right here. An example is right here. So we've got log base 4 to 4 to the power of 5. So the idea is this log base 4 cancels with the base of 4 because they're the same number, leaving you with this power of 5 as your answer. We should understand the proof behind why this expression here is equal to 5. The way to do this is to let this equal x, because technically at the moment we don't know what it's equal, so we say that's I've got a value of x. We can rearrange this equation to look like this. The way that we've done this is this little 4 here becomes our base, this x here becomes our power, and this part inside the brackets becomes what it equals. Because they've both got a base of 4, therefore x has to be equal to this 5. So x is equal to 5, and x was the original thing that we were trying to find, what this x value is for this equation. So because x is 5, it means that this expression here is going to be equal to 5 as well. So pretty much the idea is those things can cancel, leaving you with that power of 5. Situation 2, which can cancel, is when you have a base of A and it's being powered to the log of base A. So it has to be, this log has to be a power, otherwise it won't cancel. So you can see here that the base A cancels with that log base A, leaving you with whatever was with the log in the first place. So that's equals our x. So an example is right here. We've got a base 5 being powered to a log base 5. The 3 is with the log base 5, and this expression is going to be equal to that 3. Here's the proof as to why that is the case. So again, we don't know what this expression is equal to, so we let it equal x. We can rearrange this. Because we have an unknown power, we can make this power the subject by using another log. So we get another log over here. The base was a 5, so that's the base of 5 down here. And this x is what's going to be with our new log. So we get this equivalent equation right here. You can see here that we've both got logs on both sides with a base of 5 each. One's got an x and one's got a 3. Because they're equal, it means the x must be the same as this 3. So x is equal to 3. Because x was equal to what we were trying to find in the first place, and x is equal to 3, it means our original equation is equal to 3 as well. Hence that 5 is just cancelling with that log base 5 to give you that 3. Okay, so there are 3 laws that allow us to change the operations within logarithmic expressions. So these aren't cancelling things, but they are enabling us to change operations to make certain things easier for us in certain situations. So law 1, the log of a product is the sum of the logs. So the idea is we're logging a product here, it's multiplication. We can split these two things up, x and y, into each having their own log, but there has to be a plus in the middle. It's the sum of the logs. Law 2, the log of a quotient is the difference of the logs. So we're logging a quotient here, division. If that's the case, we can split the x and the y up, but instead of dividing, it becomes a subtraction. Notice that the base with the log doesn't change. It's always going to be the same. Law 3, the log of a power is the multiple of the log. So if we're logging something with a power, we can literally bring this power out to the front of the log, which is multiplying when it's out the front. And the base no longer has a power. So it's pretty much a nice way to go from something with a power to something that doesn't have a power, because powers can be a little bit annoying sometimes. Okay, so here are some common expressions which can simplify due to the above laws or properties that we went through. So these ones, it's really good to kind of take these on board because you're going to see them a lot and you want to be able to simplify them straight away. So log base a to the 1 is equal to 0. So the idea is that whenever you're logging a 1, it's always going to equal 0 no matter what the base of the log. The next one is if the log's base is equal to what is being logged, they're the same thing here, then this whole expression can be the same as 1. The idea is that log base a is the opposite of a base of a, so they're going to leave, if they both cancel out, leaving nothing, well, 1 is going to be left over. Next one, similar to this one here, but the a is being square rooted. The idea is that the square root of a can change to a to the power of a half. The log base a and the a cancel, leaving you with that value of 1 over 2. Next one is if you've got 1 over a. 1 over a is the same as a to the power of minus 1. Again, the log base a and a cancel, leaving you with just minus 1 as your value. And lastly, this one, number 5, the base is different to what's being logged. Like you've got an x here and a, they're going to be very different things. But you can change this fraction to become x to the power of negative 1. And the negative 1 power is allowed to go out to the front to multiply. So it's a nice way to get rid of a fraction. Pretty much you can change up this fraction so it becomes something without a fraction. So the handy rule there. Okay, so some example questions. So suppose that log base 3 to the 2 is equal to 0.63 and log base 3 to the 5 is equal to 1.46. Note your calculator can't deal with these, so you have to rely on this information being correct. So use the log laws to determine the value of this expression right here, which we haven't given you. So the idea is we can change this expression up so we can use these numbers here to get a value for this. So we can change this 10, so it's instead two numbers which are multiplying, 2 and 5. And two numbers that are multiplying, we can split that up using log laws to instead have them plussing together. And each of these 2 and 5 have their own log. Now we know the value of that and that because that's what they've given us. So we do that plus that, and that gives us our value for our desired expression here. Okay, this one's a trickier one, log base 3 to the 18. Now, the idea with these trickier ones, which aren't so straightforward, is we want to try and make sure we're changing 18 to some sort of expression that still equals 18. But we want to make sure that we're only using multiplication and division or powers, because with our log laws, we're changing up stuff that's multiplying, dividing, or powers. Now, the sorts of bases that we want are 2 and 5, or potentially 3 as well, because these are the sorts of things we can kind of manipulate. So I'll show you what happens. So I can manipulate 18 to be 2 multiplied by 3 to the power of 2. And these are really good numbers because we're dealing with numbers like 2, 5, and 3. And when you're timesing, remember, you can split it up so it's instead plussing, and each of these parts has its own log. Remember that this expression here, which has a power of 2, that 2 can come to the front and multiply instead. Now, log base 3 to the 2, they gave us that as 0.63. And this one here, log base 3 to the 3, when you have the same number for the base and what's being logged, like 3 and 3, that expression there has to equal a 1, as I've highlighted. So because it's 2 times 1, that's going to be 2, and that's going to be 0.63. That gives us a final answer of 2.63 for this expression right here. So these can take a while to do in your head, like to get done, but really try to think about all the different expressions you can get for this number here, 18. Okay, question 2. Use the log laws to expand, make more terms. So you're expanding these expressions. Like this is one term at the moment. Sometimes we want to get more terms to help us sort of simplify it or like make problems easier for us. So what we've got here, if we look at what's being logged, we've got 7 times x cubed. We can split up two things that are timesing into and have them in separate logs which are plussing together. So the idea is that multiplication stuff can change to a plus. We've got 7 and we've got x cubed, and this cube is allowed to go out the front and multiply instead. So this expression can be annoying in certain situations, and we much prefer to use this one instead. This one here, we've got the log of something which is dividing, so we can split the 5 and the x up with a minus in between them and their own log each. Notice that the base of 5 has to stay put with each one. And log of base 5 to the 5, the same numbers, they're going to cancel out to make a 1. And this one here can't simplify, so that's just going to come straight down. So that is kind of like the expanded version of that. Hope this helps with the questions. Good luck.